Today we're going to be looking at double replacement reactions. So if you guys take a look, we have our tray set up, and we're going to be using silver nitrate, iron 3 nitrate, and copper 2 nitrate as some of our compounds. What we're going to do is take each of these and put 5 drops of each of these compounds into our little wells. Then we're going to react each of them with these 4 different compounds. There's going to be sodium phosphate, sodium sulfate, sodium hydroxide, and sodium chloride. So simply what we're going to be doing, compound and a compound, is we're going to be attempting to do a double replacement reaction. So to get started, we're going to need 5 drops of each silver nitrate. Then we're going to take 5 drops of each of iron 3 nitrate. Next, we're going to do 5 drops into each well of copper 2 nitrate. Now that we have 5 drops of each of these compounds, we're going to see 5 drops of each are going to react of these compounds up top. And then we will make our observations and see if any of them form a precipitate. Remember, with these double replacement reactions, we're looking for something that will not be aqueous for a product. So here's our sodium phosphate. Take a look at that, and that created this yellow precipitate. So that's definitely a reaction. You take a look, that has become cloudy right here. So it looks like iron 3 nitrate and sodium phosphate made some type of new product that's a precipitate. And the same thing for copper 2 nitrate and sodium phosphate. There's some type of cloudy material that formed a precipitate. So all 3 of these form new precipitates. Make sure you write down your observations in your data table, and also what color these precipitates are. All right, coming up next, we're going to react our sodium sulfate with these 3 different compounds. So up first, so far it looks like nothing happened in A2. Let's do B2. Looks like nothing happened in B2. Let's try C2. Sometimes after a reaction happens, it's good to shake it around on a white piece of paper to see if anything formed. But it doesn't look like any type of compound formed in any of these. So for these your reactions, I would say there's no reactions visible that we see, at least for now. Maybe in a few seconds, maybe it'll take time, but overall it looks like nothing happened or formed. Let's try our next one, sodium hydroxide. Wow, that formed a precipitate that is dark brown. Let's try for B3, sodium hydroxide with iron 3 nitrate. And that definitely formed a compound as well. Color change with a precipitate. Go ahead and write that down, what color it is and that a precipitate formed. And last but not least, copper 2 nitrate with sodium hydroxide. Let's see if a precipitate forms. And it looks like one does. There's a darker blue color change in there. Let me shake it around a little bit. You can see that there's definitely something that formed in there. So it looks like the first column so far has had reactions. Second column is no reaction. Third column had all reactions. Let's try the fourth, sodium chloride. And wow, that turned a milky white color. You can see, shaking around, it's no longer clear. Let's try B4, which is iron 3 nitrate and sodium chloride. Let's see, that one didn't look like anything formed. So for this one, B4, it looks like no reaction so far. And last but not least, take a look. And it doesn't look like any reaction. Let me make that a little stir. No precipitate. So for the fourth column, it looks like just our first A4 between silver nitrate and sodium chloride did a precipitate form. Otherwise, the next two had no reactions whatsoever. So feel free to take a look at this, take a look at all the reactions and non-reactions, and take note of who forms a precipitate and if so, what color. From there, the reactions that worked, we're going to put them together and look on our solubility chart to figure out which specific compound is the one that made the solid that has that color that was created. But all right, science fam, that's it for now. But this allowed you to do your double replacements lab data table. And from there, we can continue to ask and answer questions and get a better understanding of double replacement reactions. Be well.